Okay, 5.5, triangle inequalities. So there's lots of information in this section, but I don't think it's terribly hard. Here's a basic idea here. So the longest side, I tried to highlight here on this triangle, the longest side, you can eyeball this and see that this side is the longest side. So the largest angle, of course, has to be directly across from the longest side. That should make sense. Because if you have a really short side, an extreme short side, then this angle is going to be really little. If you have a really large side, this angle that's directly across from the largest side is going to be a larger angle. That's the basic idea of everything that we have for 5.5. So largest angle is directly across from the longest side. The shortest side is directly across from the smallest angle. Logically, that should make sense. Like I said, if it's open just a tiny bit like this one is, then that opposite side is going to be a very small side. If it's open really large, then that opposite side is going to be a bigger side. So formally, the blue and the pink here are formal kind of definitions. If one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. That's what I'm saying here in a more formal way. So looking at this example, we know that 8's bigger than 5, right? We know that? Okay, just making sure. So this side is bigger than this side. That's what I have here. AB is bigger than BC. So because of that, the angles that are across from it, so the angle that's across from 8, that 8 side length of 8 is angle C. So that means angle C is going to be bigger than angle A. 8's bigger than 5, so the angle that's across from 8 is going to be bigger than the angle across from 5. Over here says if one angle of a triangle is larger than another, then the side opposite the larger angle is longer than the side opposite the smaller angle. So it's basically the opposite of what I just said a minute ago. Looking at my triangle, 50 degrees is bigger than 30. We know that. So because 50 is bigger than 30, the side that is opposite 50, which is BC, is going to be bigger than the side opposite 30. 50 is bigger than 30, therefore BC is going to be bigger than AB. We need to list the sides and angles from the smallest to the largest. Look at my first one. What is, let's do sides first because those are pretty easy. It's listed. List my sides from the smallest to the largest. Who can do that for me? It's not a trick question, it's super easy. Joshua?
ST is the smallest, and then TR is the medium one, and then RS is the largest.
Good. I hope that didn't hurt your brain. Okay, now I need my angles from the smallest to the largest. Let's start with the smallest. Jason, which angle is going to be the smallest angle with this triangle?
For that triangle.
Nope, this one.
Oh,
Remember, the smallest angle is going to be across from this.
R.
Good. Smallest angle is going to be across from the smallest side. 17 is the smallest, so directly across, angle R is going to be my smallest angle. How about my medium angle?
S.
Across from my medium side is my medium angle, which is angle S, and then my largest angle,
T.
biggest side, directly across, biggest angle. Okay, with this one, let's do angles first because that one's the easy one. Who can list my angle smallest to largest? This is like a third grade question. Sarah?
Angle L,
Mm-hmm.
then K, then J.
Good. Smallest to largest. Now what about my sides? So let's start with the smallest side. Smallest side's directly across from the smallest angle. Sarah, you want to do that one?
KJ.
Smallest angle, smallest side is KJ. What about my medium side?
JL.
Medium angle, medium side will be JL. And my largest side?
KL.
Largest angle, largest side would be KL. Not too hard, right? Okay. Moving on. Triangle inequality theorem. This one's a big one that's important. It says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. You can use this to determine a possible length of a third side or if a triangle exists. So the first way is to see if the triangles exist. This is the first kind of example. So it says, is it possible to construct a triangle with these side lengths? What this says is you add any two sides, it has to be bigger than the third side. So using this as an example, is 3 plus 4 bigger than 5? Is that a true statement? Yes. Is 4 plus 5 bigger than 3?
Yes.
Good. And is 5 plus 3 bigger than 4?
Yes.
So I tried all three scenarios. It does work. So yes, this can form a triangle. You add any two sides, it has to be bigger than that third side, and that's what I did right here. Let's do one more example. So can these three side lengths make a triangle?
No.
So is 7 plus 54 bigger than 45? Is that a true statement? That works. Is 54 plus 45 bigger than 7? I mean, you don't even have to do that. Hopefully that's like a real quick eyeball thing. Definitely. Who said no? Oh my. I will talk later. Okay, the one I'm missing is 45 plus 7. Is that bigger than 54?
No.
No. So because this one scenario doesn't work, that means no, it can't form a triangle. Very similar situation with these. So it says, describe the possible side lengths. It means what could they possibly be? When they say describe, it's not just going to be a real quick, easy answer. It's going to be describe it. So we're given two side lengths. What could that third side length be? This is what we're going to use. Values that are greater than the difference and less than the sum. Because we don't know anything about the angles. So it depends on how big or small those angles are. That third side length is dependent on those angle sides, or the lengths of those sides. Okay, so let's talk about greater than the difference. So this unknown side, that third side, is what we're trying to figure out. So we can say x is greater than the difference is subtracting. So we know that it is bigger than 8. It can't be 8, but anything bigger than 8. And less than the sum. So we're going to do less than 12 plus 4. So x has to be less than 16. I will accept this, both of these answers. If you want to take that a step further, we can rewrite it this way. So we said less than 16 and greater than 8. So this one I just rewrote. This one I kind of flipped it so that I can read it kind of from the center out. If this is super confusing to you, writing them separately is perfectly fine. Okay. Ideally, I'd like you to write it this way, but I don't really want to spend a whole lot of time talking about this notation. This is important, though, that you have both of these in here. So it has to be bigger than 8 and less than 16. So it could be 9, it could be 10.5, it could be 13, it could be 15.9. One more. So 9 and 18, we're going to use the same idea. Bigger than the difference, and you're never going to have negative numbers, just the bigger number minus the smaller number. So x has to be bigger than 9 and less than the sum. So if I wrote this with a complex inequality, so either this answer or both of these answers is correct. One more example. So it says, describe the possible values of x. We're still using this idea, greater than the difference, less than the sum. So what we need to concentrate on is this side. So we're going to use this side kind of as our unknown. So we're going to say 4x plus 2 has to be greater than the difference, 18 minus 8, and 4x plus 2 has to be less than the sum. So I'm setting them up very similar to what's over there. The only difference is I have to simplify on this side, or solve. So when I simplify, subtract 2, divide by 4, x is greater than 2. Something wrong? Did I flip it? What's wrong, Julia? Go ahead and talk.
Don't you have to reverse the symbol when you divide or
I'm glad you
multiply?
asked that. You don't.
No.
The only time you flip this symbol is if this 4 was negative. So our rule is that you flip your symbol only if you're dividing or multiplying by a negative number with inequalities. So this one, you do not have to flip the symbol. I'm glad you asked that. So x is greater than 2. Over here, very similar situation. Subtract 2. Divide both sides by 4. So again, you don't flip the sign because 4 is positive. So x is less than 6 and greater than 2. So the easiest way to change it from this to this, look at what it's pointing at. It's pointing at the 2. And in this scenario, it's still pointing at the 2. It's kind of the easiest way to remember it. So again, either these two together as your answer or this as an answer will be accepted either way. Okay? Okay. Homework's over there on the board. So we're going to do homework time. I'm going to give you back your quizzes and talk about any corrections that you need to learn from your mistakes. And then I'm going to hand out your take-home chapter 5 test at the end of the block that'll be due next Thursday.